Brightstorm has thousands of high-quality videos covering all major subjects. Please check out more at www.brightstorm.com.
Solving rational equations where I'm going to have to use the quadratic formula. Okay, in both these problems, numbers 1 and 2, on the left-hand side I have a difference of fractions. So I like cross-multiplying, but I can't cross-multiply unless my left-hand side is just one fraction. So what I'm going to do for both of these guys is find a common denominator on the left-hand side, combine those fractions so that's one fraction, and then I'll cross-multiply. Okay, so you might have seen I already sneaked in there a common denominator on the left-hand side. And so I'm going to combine that. So now my left-hand side looks like 3 minus x squared minus 2x all over x plus 2, and that's equal to 4/3. Now I have fraction equals fraction, so I can cross-multiply. 4 times x plus 2 is equal to the product of 3 times, I'm going to write this in standard form, just flipping the order, being careful to keep the signs in the same place. Okay, negative 3x squared minus 6x plus 9. Okay, so now I have a quadratic equation. I'm going to set it all equal to 0. And then, if I'm lucky, I'll be able to factor this thing, but if you read the title or you heard me introduce this little lesson, you'll know that this thing cannot be factored. I'm going to have to use the quadratic formula in order to solve for x. So, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Got to simplify that. 10 plus or minus square root of 100 plus 12. Square root of 112. Well, I know that 16 goes into 112. It's 16 times 7. Square root of 16 times square root of 7. So really this could be 10 plus or minus square root of 16 is 4 root 7 over negative 6. And the last thing I want to do is simplify that. I'm going to simplify 10 over negative 6 and also 4 over negative 6. It will look like 5 over negative 3 plus or minus 2 root 7 over 3. Negative 3. Those are my two solutions. And so, of course, you always want to check if those things are extraneous. And in this case, I can tell they wouldn't be extraneous because it'd be extraneous if I was dividing by 0 in my original problem. And if I plugged in 0 into those original values of x in the denominator, I would not be dividing by 0. They're not equal to negative 2, so I'm fine. The only excluded value for problem 1 is negative 2. Let's look at problem number 2. Same idea. On the left-hand side, I'm going to find common denominators so that I can make that one fraction. I'll have x over 6x minus 6 over 6x. That combines to x minus 6 over 6x. Now I have one fraction on the left-hand side, so that's good, because now I can cross-multiply. 4 times 6x would be equal to the product of 3x squared times x minus 6. That's going to be 3x cubed. Oh man, I have to deal with x cubed. Well, if I'm lucky, there'll be a greatest common factor that I could factor out with x. Minus 18x squared minus 24. Yeah, see how 3 goes into all of those? In fact, 3x goes into all of those. So I can factor out 3x, and I'll be left with x squared minus 6x minus 8. Okay. So, what I want to do is use the zero product property to tell me my solutions for x. This bit right here tells me that I think one of the solutions is x equals 0, and my other solutions will come from doing the quadratic formula here, because that trinomial cannot be factored. But, before we move on, this is an important bit. I just said that x equals 0 is one of my solutions, but check that in the original problem. If x equals 0, I would be dividing a fraction by 0, and that's not allowed. This is what's called an extraneous solution. It's outside the domain. X could not be equal to 0 ever for this problem, because then I'd be dividing by 0, and in math that's undefined. Let's see if I can find some other solutions that do work for my quadratic formula. Okay, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So that's going to be 6 plus or minus the square root of 36 plus 32, which is 68. Now, what goes into 68? What perfect square? Well, 4 goes into 68, so I can make this square root of 4, and then what's left over is 17. And then if I reduce that, I'm going to have 3 plus or minus root 17. Those are my solutions that I believe will work, because if I plug those into my original problem, I would not be dividing by 0. Okay, so a lot of times in math you get integer solutions, and that's great, but when you're working with particularly real-world data, you're probably not going to get integer solutions. You're going to get something that requires a quadratic formula, and that's what we've been looking at here. What you want to do is make sure that your quadratic formula solution is not outside the domain. It's not extraneous. The way you check is by putting it back into your original problem and make sure you're not dividing by 0.
By 2. I can't do this with you two laughing back there.
Work it. Work it.
So if we had, no, that's not right, 3 coplanar points.
So have you ever gotten off an airplane?
Has to be less than. Yeah. Dang.
Is it like 500 degrees in here or what?
All right, so when you're in chemistry class, you're going to be doing a lot of work. You're going to be starting over.
So as an example, we could consider like you've got a chain hanging from two fixed.